Hi everyone, how it's going? My name is Evgenii. I work at Microsoft as senior software engineer, and today I'll tell you about cybersecurity and supply chain and phishing attacks that can happen in geospatial products and how we approach security in general. Yeah. So about me. I'm really passionate in cybersecurity. For example, when I was 14 years old, I found infinite money glitch in one of Russian banks. There was some stuff like you have 30 rubles, you convert it to $1, and then you convert $1 cent to euro cents, and because of rounding error, you get 1 euro cent. That it's like 40, like 1 euro is 40 rubles. So you can repeat this and get infinite money. Also in my cybersecurity portfolio, there is like probabilistic authentication by passive, another bank. And I started at Yandex, and first I found XSS vulnerability there. It's actually a type of web vulnerability I will be talking mostly today. And I also educated people about how to write secure code. So yeah, here it is. Let's talk about why cybersecurity matters, because this is not something that gives you money directly. Actually, you're spending on cybersecurity, not getting something in return immediately. It's not like revenue or growing your user base, but it's really important because every big company should invest in cybersecurity. Our systems are complex. We live in an interconnected world. And if someone got hacked, it's really bad for users, for reputation, and etc. So that's why we should care a lot about cybersecurity. And there is three stuff that I should mention. That's availability, integrity, and confidentiality of data. So availability means if you have like some maps product and you want to go home, like open your maps, type address and go, you want system to be available. And that's not only DDoS attacks that can threaten availability, it's also like some credentials stuff or privilege escalation. It also can lead to broken availability of service. Integrity, it's, for example, you add some like link to like favorites, and you want these favorites to stay there, not gold, not change or something. And confidentiality, it's like you have history of queries, you have location history, and you want this to stay private. What is XSS vulnerability? XSS stands for cross-site scripting. You may ask why not CSS? That's because CSS is styling tables. That's like, and XSS is like more cool than CSS. So that's why. It can affect only web, but you know that some modern applications, native applications, are really web-based inside, so it also can affect them. And how it works, there is some code that is being misinterpreted by browser. No, there is data, and it's being misinterpreted as a code, and browser actually executes this. And this allows attacker to get like something with your permissions, to like drop database on production or to change everyone name to John or do anyone they want. XSSs can be stored, reflected, and DOM-based. And let's deep dive on what type of XSSs do exist. There is like some vector that names phishing attacks via DOM or reflected XSSs. It's not like classical phishing where you have fake login page and you just like say, here's my login, here's my password, and two-factor authentication code. No, you can just like get a website about some nice cats. You just scroll that's nice cats, and you have iframe on your service that is being injected with code. It's like reflected that names your web page, reflects some input. And this input is being mistreated as code. And there is also supply chain attacks. via stored XSS. It don't requires some interaction. You may just open your tooling, and because one of data sources is being polluted, and you have like malformed data there, you also can get hacked by this in same way. Like you have data, it's being misinterpreted as a code, browser executes it, yeah, they can do anything. And here is example of what we had in Microsoft in one of our internal tools. You can see that there is like some window here. It's classical way to display XSS because you need only one function. You call it and you have some visual clue that it's actually been like hacked because you got that code executed. And let me show how it works. Here is exploit. It's maybe not so obvious how it works, but here we submit a form so that our vulnerable endpoint gets data, and it reflects this data back. And because it do not filter scripts, we get script and execution. Here is example how it works on view source. So you get a result, and here you see that script that is being executed. That's reflecting of what is being passed. And here is how to fix this. This was real production code. Now it's changed to this. So what happens here? We do not pass our data directly. We filter it and put it in one of the divs. And then in JavaScript, we read it from like JSON parse from inner text. So that's this way we read only sanitized already stuff. And there is also something named depends in depth and Swiss cheese model. It's important to talk about. If you take Swiss cheese and try to see through, you cannot see through Swiss cheese. But if you have some slices of Swiss cheese, you can actually see holes, and that's the layers of your system. So, for example, you may have something vulnerable to XSS, but you don't have permissions to do anything, or it's like not accessible via frames. If someone tries to inject frame with this stuff, it just will say, "Oh no, that's we have special header that says we do not allow injecting in a frame, and it will not work." So more layers you have, more secure you are. You do not need to have foolproof any layer. Actually, layers can be like with some holes, with some problems. But because you combine a lot of layers, that's how you secure your system. And also there is a countermeasure to XSS type of attacks. It's named content security policy. It tells browser what it can and cannot execute. So you have like some inline scripts. You need to move them on your web server. And then you tell browser in content security policy that it should not execute inline scripts. And if you do so, if you have XSS, it will not work because browser knows that it's not possible to do. And it's effective only in modern browser. I hope no one using Internet Explorer now. So yeah, it works in a lot of browsers, just some kind of modern browser, it's fine. And you also need to avoid unsafe inline for scripts. Here you can see that in styles we have unsafe inline. That's not good, but it's kind of trade-off you need to have because there is a lot of inline styles. If you want to get rid of them also, you need to refactor even more. And styles are not that important comparing to scripts because scripts can actually execute code. But if you can like write styles that is being loaded from your page, it's always nice. So yeah, here it's how it works. Thank you for watching. If you have some relevant questions, feel free to ask.
Thank you, Evgenii. Yeah, yes, Kate.
Thank you very much for your presentation. And I want to ask how you choose levels of your testing the security. I mean, if you choose to test security with some AI or maybe with some API levels. So how do you choose your testing?
You
Thank you.
can you can do many stuff to actually make your system more secure. For example, you can run checks on code that find some bad patterns. You can update your packages to not have old packages. You can do some manual testing. And you mentioned AI. AI is really empowering people to do more. It's a good thing to have. But it's important to know that security bugs are not obvious. It's like not a button of different color or some layout problems you can see and ask AI to fix. And because of more usage of AI, it's more attention should be paid to like securing system, to like implementing some scanners, to educate people who work on code to produce actually good code. You can also use AI as a scanner for vulnerabilities. It's also possible. So yeah, that's how it's done.
How do you choose how much data they send to the maybe OpenAI or some another company? I mean, do you check this data or how it works?
It's not seems related to presentation. Sorry, can you please?
Oh, yeah, okay. Later,
Yeah, okay, okay. Any questions? Yeah, there is. Can you
There
give,
is one.
please? Yeah.
Thank you for your presentation. It was very interesting. You mentioned that sometimes you can use an AI to find the vulnerabilities, but how actually effective is it? Because recently I read that, if I remember correctly, curl refused to accept any reports on vulnerabilities if they were made using AI because they received a lot of them and they didn't make any sense. What is the state of the art in the industry? Is it something that we can trust, or we should just wait until they get better? Thanks.
Oh, you mentioned that situation with curl library. It's that's like for context for others to understand better. Guy who is responsible for curl, that's library for HTTP requests, says that there was a lot of submissions of AI generated bug reports, and there was like some stack traces. And when they deep dive into that stack trace, they see that it was like made up. Just AI hallucinated that stack trace, and it refers to functions that not exist. So that's really important to validate that stuff before using. And AI is actually a broad term. It's like artificial intelligence. It may be large language models. It may be a bunch of ifs. It may be linear regression. There is a lot of stuff named AI. And actually, to like use it effectively on vulnerabilities hunt, it's better to have some validation that can be automated. Like you ask, for example, LLM to make to see code and see some problems, and if it sees some problems, you may ask for exploit, and you can actually run this exploit and check is it like working or not. So yeah, AI may hallucinate. It's a problem of LLMs, and how you can fix this? You can actually test this stuff like more automatically. Yeah, that's that answer.
Do we have more? One here?
Thank you for the presentation. I have a kind of special question. I don't know, can you actually answer me? But right now at my job, I'm working on the security of third-party libraries. How you doing it in Microsoft? Actually, it's kind of interesting. Do you have, I don't know, special team which are reviewing these third-party libraries, and you fix versions, or you have loosened versions, and some project can download minor versions automatically, or you fix them, and how this process works at Microsoft, because actually I don't know how to do it better at my position right now. I'm proposing that we should fix all the versions. I'm front-end developer, so we doing it on the packages on, so we just fixed all the versions, but I think it's not the ideal way, but I'm interested in how you are doing that.
Yeah, I can actually answer from our team, and because Microsoft is really big, I cannot tell about everything. I don't actually know. Maybe some people do something else, but in our team we have some automatic scanners. There is stuff named CVEs. That's common vulnerabilities and exposures. So you have database, you have feeds of vulnerabilities. And you have some system that just sends you alerts and tickets about, actually on GitHub, that's Microsoft's project, there is a thing named Dependabot. I can recommend you using Dependabot in a project. It's very nice and available for outside people thing. It scans not only for NPM, it can also scan Python, I think maybe some in other languages that are popular also. And it can just tell you, hey, there is some package, it's outdated, please update it. And also send pull requests. So that's a way how you can do if you do not. But yeah, we have actually some scanners that will alert us, and we know about some problematic stuff, and we can go and fix it.
Great, we have time for one more question, if there is one. If not, I would ask you for a big round of applause for Evgenii. Thank you, Evgenii, it was great.